All right, let's get started, everybody. Good morning. Our last class of the week, and hopefully I'll make it a good one for you. We got a lot to do today. One of the things I'll talk about that I didn't see in my slides, and sometimes when I go from one class to the other, I forget to put something, but when we go through the problem set for chapter 3, I'll talk about homogeneous and heterogeneous, because I forgot to talk about it. It's part of the problem where I'm trying to put in 8 hours of lecture per week in the summer into 5 hours. It's interesting. Luckily, you have my videos. Speaking about videos, if you look at Blackboard, you'll see that there's a new folder. It's called Dr. White's YouTube links. I have a link both to my Chem 1211 Zoom meeting videos and also my 1105, which is similar to what I'm doing here. One thing I should point out, the 1105 in the early 2020 weren't that good because I wasn't used to the room, and they get better. And when you get to 2019, they get real better, much better, because it's a smaller room and you can see the board better. All right. What I'd like to do is, first of all, I'll say there was a mistake in the lab we'll do today, or you'll do today later, and I'll post a correction. I have a wrong volume for the volume of diamond plus water. Oh, is that good? I love my tea in the morning. All right, what I'd like to do first, and also today after our lecture, I'll go through, anybody wants to stick around, how to eliminate test anxiety. I'd say it's free of charge, but you have to pay to get in my class. So it's somewhat an extra. I don't know why I'm getting wrong titles. All right, what I'd like to do today first is go through the lab, get that out of the way. This lab, which has a mistake, and I'll fix it, is available in the assignments area Blackboard for you to download, both as a PDF and as a Word file. If you do not have a printer, or if in my case, my printer just broke, I've got to buy a new one, and you don't have a working printer, feel free here, just write out. You don't have to write out the whole lab, just write out things you have to calculate and questions you have to answer. This is due next Tuesday. All right, today's lab deals with density. Density is an important property of matter. By definition, density is weight per volume, Formula 1. Now, to calculate the density, you need to measure the weight and determine the volume. Now, and then use this formula. An important aspect of density is that lower density substances float in higher density liquids, and higher density substances sink in lower density liquids. And that's an important thing you should know, which is why if you take a cannonball and put it in a barrel of water, guess what? It sinks. Now, if you remember, if you've ever seen on the old movies, the old cork ring life preservers, those circle life preservers, those were filled with cork. Cork has a lower density than water, and that's how it helps you float so you don't drown. And so, important thing, lighter densities in liquids that are lighter than the density of the liquid float, and in a liquid, densities that are heavier substances than of the liquid. Wow, you like that? Well, that's a new one. Stop doing that, Dr. White. Okay. If you have a cannonball, it goes whoop, float, sinks right away. Now, in this lab, you'll be determining the density of a liquid, a solid, and an unknown material. That makes it more exciting. By measuring the weight and volume. If you were in the lab, you'd actually be doing this. Now, to measure the weight of the volume of a liquid, you'll be using a graduated cylinder. And if you haven't used a graduated cylinder, here's a nice YouTube video that talks about it, and also talks about the meniscus, how instead of reading straight across, the liquid is like a U, and you read at the bottom of that. Unfortunately, you won't be using a graduated cylinder today because you're at home, but this video will show you the experience. Now, how do you measure the volume of a solid? We do that by a technique called water displacement. And what you do is you have a graduated cylinder with a certain amount of water in there that you measure. Then you put the solid, hold on, time out. And I'm back. And how many people do you know have a graduated cylinder? It's on my table in my living room. But anyways, this is a graduated cylinder. It's like a measuring cup. And you'll put in some water, measure the volume. If you were in the lab, then you put the solid in there and the volume will go up. And the difference between the two volumes of the initial water level and the final water level will be the volume of the solid. Now you know I'm a chemist. And that's how you do it. And this video shows you in real life how if you were in the lab, you'd be determining the volume of a solid. Now, there are three parts. Part one, octane is a component of gasoline, the major component. That's why they call it the octane number on the gas pumps. If you're taking organic chemistry with me, I would be teaching more about octane and gasoline, but do I have time? Yes, I do. Time out for a public service announcement from me, Dr. White. As you know, if you don't, you now do, for many decades, I worked in the chemical industry. And one company I worked for made additives that are used in gasoline. And because of that, and because I was a senior R&D research and development manager, and I also could talk to clients, I went and talked to clients. So I went to the major gasoline companies, and because we were selling it, I found out from most of them that they all knew who was the best gasoline to buy and who was the worst. And this is my own personal opinion, but it's from professionals too. The best gasoline has always been for decades Shell. Mobil is almost as good. And the worst gasoline, now called BP, it used to be Standard, is don't buy it. One reason, about 3 years ago, a refinery in northern Indiana near Gary for Standard, BP, I still use the old name, put out real bad gasoline. And in the Gary, Indiana area and that part of Illinois by there, the gasoline was so bad, it destroyed almost 3,000 car engines that BP had to pay to be replaced. And for decades now, they've always been the worst. Stay away from that. That's my own personal opinion. Now, another thing, quick thing that has nothing to do with tests, but it's public service announcement from me, Dr. White. You have 3 different grades of gasoline. I always buy the lowest. I have an SUV with a good sized engine, and that has certain additive packages that keep things clean, your chemicals they put in the gasoline. Now, the highest octane has the best additives. And about every 3 months, normally I don't let my gas tank go below half. That's just a personal thing of mine. But anyways, I'll let it go down to a quarter full, and then I'll fill it up with the highest octane, most expensive gasoline. And that's because every once in a while I use those extra additives. That's why it's more expensive, one of the reasons. And it helps keep my engine clean. And I've got an older car and it's been running fine. And that's because I do stuff like that. All right, back to the lab. In the first one, you'll be doing octane, which is a liquid at room temperature. So you'd pour some into a graduated cylinder and find the volume right here. Now that same graduated cylinder, you'd weigh empty, and then you would measure it with the amount of octane. And the difference of these two numbers is the weight. And the density, you divide the difference by the volume and you'll get the density of octane. And these two numbers you have to calculate. Next one, I figured, oh, I'm going to go really treat you people to something special. Let's do a diamond. So you each got a diamond from me now. And
Dr. White?
Yes.
Can you repeat it, please? I didn't understand how to do the weight and the density.
All right. Now, the weight is the difference of the top one minus the smaller one.
Okay.
And the density is Formula 1. Take the weight you just calculated and the volume you're given and divide it. Okay?
Okay.
And that's how you do it with all these. See where it says use Formula 1?
Yes,
So
yes.
you would take the weight you just calculated and divide it by the volume. And by the way, thank you for your question. There's no such thing as a dumb question in my world.
Thank you.
Let's move on to diamond. I made a mistake and I'll correct it later today. I didn't have enough time. A diamond, as you all know, is a solid at room temperature. And as they say in the movies, it's a girl's best friend. They actually had a movie about that. And I think it was with Marilyn Monroe. But continue on, you'll measure the volume of the diamond by displacement, and you'll weigh the diamond. Be sure to return your diamonds to me. All right, now this number I've got to change, and later today I'll re-up this and I'll send out an email letting you know what the correct volume is, because this is the same and you get 0 and it won't work. But you take this number, subtract this number when I correct it, and you'll get a volume. Milliliters is the unit of volume. Here's the weight, and you divide the weight by the volume once they give you the right number, and you'll get the density of the diamond. Now, let's do something exciting. The density of an unknown material, a metal. Well, it's a solid at room temperature. And to make it interesting, the DuPage County District Attorney needs to know the identity of a metal in order to convict a person of a heinous crime. I'll let you fill in whatever heinous crime that person needs to be convicted of. Now, you must determine the identity of the unknown by determining the density of the unknown metal. So thereby helping the district attorney convict the person of the heinous crime. The metal is a solid at room temperature, so you'd use water displacement to get the volume. You'll measure the weight directly. Here I got it right. The difference, this minus this, is the volume. Here's the weight. Weight divided by this volume will give you a density. And if you were doing this in a lab, we would have unknowns for you to do, and you would do this. Now, you'll get a density, and then how do you identify it? Well, your metal is one of these in table 1. Could be aluminum, zinc, iron, copper, silver, lead, and gold. Mercury is a liquid, and obviously water and ice and a feather are not metals. And you'll use that and put the name in there. If you don't, I'll take off a point. Or if you get it wrong, you shouldn't. This is a fun lab. Now, besides that, I have a series of questions at the end of the lab, which you need to answer when you hand in the lab. You do not have to write out the whole question. Just put your answer. I better tell you a secret about Dr. White. I always give you way more room on something to write in an answer than you really need. But if you want to take up all that room, you can. But usually I give you more room than you'll ever need to answer anything. Shh, don't tell anybody. It's a secret. And I have a series of questions here, like determine which of the following substances will sink or float when you put it into a bucket of liquid lead. Lead, if you heat it up, will be a liquid, even though the feather would burn, but just pretend it won't. And what you'll do, the lab is due this one with the answers and the data, the densities you calculate by next Tuesday. That's the due date. Later today, I'll be posting in Blackboard how to create a PDF file from pictures from your cell phone if you don't have a scanner. And it's quite simple. Last semester, students got it. I had a class of 1105, 48 students, and all but one of them was able to do it. The one who couldn't, well, I don't know. It's not that hard. Any questions on the lab?
I have a question, Dr. White. Should we do it in directly in the computer in documents and then send it to you?
You can do it any way as long as I can read the answers.
Okay.
Any electronic way. You
Okay.
don't have my home address, so you can't put it in the mail and mail it to me with this USPS.
Okay.
By the way, I really respect the people of the United States Postal Service, because in this, how should I say, trying times, they're out delivering the mail. In fact, twice now in the last couple of weeks, and they like it. I'll put a post-it above my mailbox by my front door, thanking the mailman and all the people, and mysteriously it disappears, and I'm sure he takes it, or she, we have a guy now, he takes it back to the post office to show other people, which makes them feel good and makes me feel good. Thank the people who are risking their lives to help you out. I do. That's part of being a senior manager. Thank people who do their job. All right. Let's go through the practice problems for chapter 3. First, let's do the temperature. Remember, you'll be given these formulas that are in these problems for test number 1. Also, it's time for a second public service announcement from me, Dr. White. Your grade is determined by total points, and test number 1 is always the test that everybody gets the highest average, the most points. So you should be studying hard for test number 1. You should study hard for all the tests, but especially test number 1, because that's the one easiest to get the most points. Public service announcement from Dr. White. Oh, I did look into using my tablet on PDF files, and it's not that easy. In fact, they really make it difficult. But anyways, let's do a couple of these. Say 3 or 5 points on a test. If the temperature of a liquid is 134 degrees C, what's the temperature of the liquid in degrees F? What I like to do, and you don't have to do it, but it pays to show your work. 1, if you make a mistake, I can give you partial credit. and 2, it helps you get the right answer. What are we trying to find? Degrees F. What are we given? This number. You will be given an important information, this formula. You need to know that's the one you use. You put the number in here, 134. Now, 1.8 is an exact number. 32 is an exact number. They don't play a role in determining significant figures. Therefore, this is 3 significant figures, and therefore my answer when you put it in your calculator is 3 significant figures. I don't think I'll have time today, but Monday after class, for those of you who don't know how to do scientific notation in your calculator, I'll show you online after our Zoom meeting. All right, now let's do number 3. If your oven temperature is 353.5, really nice digital readout, what's the temperature of your oven in degrees C? So we're trying to find degrees C, and we're given Fahrenheit. The formula is degrees F minus 32 divided by 1.8. Now, common mistake. Students divide each number by 1.8 before doing the subtraction. No, always do what's in the bracket first, subtract the 32, and then divide by 1.8. Otherwise, you'll get the wrong answer, which I don't want that to happen. Now, 32 and 1.8 are part of the definition. They're exact numbers. Therefore, they do not play a role in the answer. The only number that's measured is degrees F, Fahrenheit. And notice that's 4 significant figures. Non-zero numbers are always significant. There are 4 of them there. Therefore, when you do the math, do this first, then divide, your calculator gives you a lot more past the decimal. You have to round it off to 4 significant figures. Why? Because you start out with 4. The only number in this equation that used to determine how many significant figures in your answer is the Fahrenheit, because 32 and 1.8, once again, are exact numbers. Now, temperature of gas is 303 degrees C. What's the temperature in Kelvin? I don't know why they never call it degrees Kelvin, but they don't. One of these days when I don't have anything to do, I'll look it up on the internet if I can find it, but not now. So we're trying to find Kelvin. We're given degrees C, centigrade, and now, or Celsius, I always say the wrong name, and Kelvin is equal to degrees C plus 273. This equation will be at the end of test number 1 on a page that says important information. And sometime this weekend, I'll post in the lecture folder important information test number 1, so you can see what you'll be given. I'll also post there the periodic table you'll be given when you can download when I post the test. First, I got to write it. But anyways, so Kelvin equals degrees C plus 273. 273 is an exact number. This has 0 significant figures past the decimal. Remember, this is an addition. This is an exact number, and here's your answer. And that's how you do temperature. Let's look at the other one. 2 points. What is one? I'm only asking you to learn one of the 4 branches of chemistry. The best is organic chemistry, because I'm an organic chemist. Biased, am I? Sure am when it comes to that. And the others are inorganic, which I never like. Physical and analytical are good. All right, what is matter? Anything that occupies space or and has mass, but I probably won't ever ask that on test, but this is very important. What are the three states of matter? Solid, liquid, gas. I don't think I ask it here, but you should know a solid has definite shape, definite volume. Liquid has indefinite shape, but definite volume. And a gas has indefinite shape and indefinite volume. Now, give an example of a pure substance you use in your life. Water is pure, gold is pure, oxygen is pure, nitrogen, I could go on. All right, name a mixture that you could use, you could purchase in a grocery store. Well, milk is a mixture, I'll talk more about that. Mouthwash, pop, mustard, ketchup, a whole lot of things in the supermarket are mixtures. Now, here's where I didn't explain, and let me try something. Probably I covered in another chapter, but later when we talk about solutions, I'll give you this definition. By the way, tonight at midnight, I'll be giving decoding lessons how to read my handwriting. Now, homogeneous, it's a mixture that's the same throughout the mixture. Heterogeneous, it's not the same throughout or consistent throughout the mixture. Now, what would be an example of homogeneous? If I took sugar and water and mixed it together, I tell you, I was always the first one down in a spelling bee. Now, something that's heterogeneous, sand and water. If you take some sand and put it in a beaker or a glass of water, it will sink to the bottom. You'll have water on the top and the sand on the bottom. It's not the same throughout, and that's heterogeneous. If you took salt and water and mixed it together and shook it up real good, the salt dissolves and it's the same throughout, the same amount of salt and water everywhere. Also, air you're breathing right now is a mixture of oxygen and nitrogen gases mainly, and that's the same. Hopefully, if you're right here and you walk over there, you won't go, I can't breathe anymore, no oxygen. Why? Because it's a homogeneous solution. I bet you never, a mixture. Next time you're with your friends, neighbors, and loved ones, like at a party, you can say, do you know you're breathing a homogeneous mixture of oxygen, nitrogen? Don't do that. Don't talk chemistry at a party. You'll lose friends quick. So if I ask you, ah, is oil, vinaigrette, salad dressing homogeneous or heterogeneous? If you've ever seen oil vinaigrette dressing, you shake it up and you pour it on your salad. But if you put the bottle back down, after a while, you'll see two layers and it separates. One is the oil, the other vinaigrette, which is water mainly. And I'll teach you more about that later in the semester. And that will be a heterogeneous mixture. Gasoline, hopefully you're getting good gasoline, not BP, is homogeneous. If it's heterogeneous, well, you're going to have major problems. And if you think about it, let's think of a couple more. If you open your refrigerator and pull out a bottle of ketchup, barbecue sauce, or mustard, it's the same throughout the bottle, so it's homogeneous. Now, let's see. If you pull out, this is a good one. If you pull out a bottle of pickles, it's heterogeneous because some places are pickles, some places are the liquid in the pickle jar. It's not pickles and liquid, it's the same throughout. So next time you're in your kitchen, open your refrigerator and amaze yourself with all the chemistry going on in your refrigerator. Now, I asked you to learn the chemical symbols, say 1 point each on a test. Give the chemical symbol for carbon, C, silver, Ag, sodium, Na, nitrogen is N. Or I could ask on a test, give the name of the element, Na, sodium, Mg, magnesium. I've only asked you, my favorite, argon. Why? Because I used that a lot when I was in grad school getting my PhD. I used a lot of argon to run my reactions under to keep them dry, all moisture out of there and air. Krypton, remember in our universe, it's a clear, colorless gas that will not kill Superman. Now, we talked about physical and chemical properties. The fact that water freezes at 0 degrees C is a physical property. I have an example of the same thing I repeated, sorry about that. Iron can rust, that's a chemical property. Gasoline is flammable. Give an example of a physical change. Well, when water boils or ice melts. Give an example of a chemical change, iron rusting when you burn a candle, and when you eat food. In your stomach, your food is undergoing massive chemical changes to help keep you alive. Warning, I should give you a warning. The last biology I took was freshman year of high school, and that was long ago, too long ago. Not that there's anything wrong with biology, but even by then I knew I was going to be a chemist. By then, by 8th grade, freshman year of high school, I knew I wanted to get into chemistry. And I did. So be careful when I talk about biology because my knowledge is limited. All right, let's look at what state of matter has definite shape and definite volume? Solid. What state of matter has indefinite shape, indefinite volume? It's a gas. And finally, you should know, if I ask this on a test, 1 or 2 points, what state of matter has indefinite shape and definite volume? That's a liquid. Any questions on chapter 3? Hold on. Oh, it's hard to do this morning. Chapter 3. Questions, problem sets. Going once, going twice. Well, let's move on. before we move on, I mentioned earlier, but I'll mention again, I'm now keeping up to date, usually within about 12 hours after our lecture or less. I'll post on the YouTube channel for 12/11. Once again, I'm a YouTube star. The video for this Zoom meeting. Just to let you know, to actually process the video, which I do, takes me about 20 minutes, then about another 40 minutes for my software to actually process it. I've got two monster machines that have 7 and 8 core processors that are super fast. And it takes that long. Then it takes about an hour and a half, even though I have fast internet. YouTube is slower than molasses to upload it to YouTube. So it's a couple hours from the time I start to finish, not all where I have to work. Oh, do you feel sorry for Dr. White? Does your heart bleed for me? All right, let's go back to chapter 4. And chapter 4, we're talking finally about the good stuff of chemistry. And I talked about an atom. An atom is the smallest particle of an element that retains all the characteristics of that element. I talked about how compounds contain more than 2 types of atoms. And I talked about subatomic particles. If you remember yesterday, I talked about, hint, you should know this, electrons, protons, neutrons. Those are the 3 subatomic particles that make up an atom. Electrons have a negative charge. Protons have a positive charge, you should know. Neutrons have no charge. I talked about Thomson's cathode ray experiments, and what really important you should know, that Thomson's experiment showed that electrons have a negative charge. And that was an important discovery. Now, let me talk about Rutherford's gold foil experiment. Rutherford was a chemist around working around 1910, give or take a couple of years. And he did a very important experiment, but time for some knowledge about getting your PhD. When you're getting your PhD, you join a research group at the school, graduate school you went to. That's part of the choice, which school I went to, what professors were working in areas I was interested in. And I was lucky enough to be able to join Dr. Rush's group in synthesis. Synthesis is a fancy word for making. And my training is making organic molecules that solve problems. And to this day, I still do that, consulting. Now, when you're a grad student, the professor has a certain area he's interested in, said, here's a problem I'd like you to work on. And he helps you, and you have to do certain experiments to solve that problem. Or fancy word time, warning, you elucidate something. You may bring understanding. Elucidate means to make it understood, a certain concept or something. My PhD thesis helped elucidate the mechanism of the sequential Michael reaction, which most chemists wouldn't even know what I just said. Most organic chemists wouldn't know unless you worked in the area I did. But anyways, when you're working out in a lab, you do an experiment and you get unusual results, and you take it to your supervisor, your advisor, in my case, Dr. Rush, and look what I got. And he said, why don't you do it again? It might have been a fluke, you did something wrong. And you get the same results. And he said, let me come out there in the lab and watch you do it again. And you see that you did do that. Well, in Rutherford's case, they had a piece of gold foil and set high energy particles at it, sort of like shooting cannonballs at tissue paper. and you expect the cannonballs to go right through. Well, it turned out it didn't. Some of these high energy particles were reflected back. They had what's called a phosphorus screen that would light up to show where the particles were going after it hit the gold foil. And I can just see Rutherford, graduate student, was doing the experiments, saying, what? It came back. You made a mistake. Do it again. What? It still came back? Let me go out and watch you. And it came back. And this was amazing because it was like shooting a cannonball at a piece of tissue paper, Kleenex. I got to find a way to get product kickback money when I say a brand name. But anyways, and the cannonball bounced back from the Kleenex. Well, what Rutherford was able to elucidate, fancy word, was the fact the center of the atom. And we call that the nucleus. The nucleus, you should know, is the center of the atom, and the nucleus is very dense and extremely dense, and that's where the protons and neutrons are. And you should know that. I'll say it again. You should know that Rutherford's gold foil experiments dealt with the nucleus, which is the center of the atom. And the nucleus contains protons and neutrons. Now, all around the nucleus, protons, neutrons, all around it is the electrons, and I'll talk more about it in the next chapter. Where are the electrons? Because that's the fun part of chemistry, the most important, but that's my personal opinion. So that's Rutherford's experiments in determining that the atom is made up of a nucleus, which contains the protons and neutrons, and around the center, the nucleus, we have the electrons. Now, if you look at a periodic table, and we'll go through this more, but let me get one up real quick. Everybody see the periodic table here? Yep, thank you. Now, if we look at the periodic table, you'll see in the upper corner, some is the upper right, left, some in the upper right, this is upper left. You'll see a number there. That's called the atomic number. Atomic number for hydrogen is 1. Atomic number for my favorite element in the periodic table, carbon, is 6. Oxygen, I like 2. 8, nitrogen's pretty good. And, oh, let's do a big one. Bromine is 35. The number in the top of the box of a periodic table is called the atomic number. This number is very important. And the atomic number, by definition, is the number of protons. Now, all atoms have a net zero charge. All atoms have a net zero charge. Therefore, protons have a plus charge, and you have a net zero charge. Electrons, which have a negative charge, you have to have in the elements the same number of electrons and protons. So once you know the atomic number, you know the number of protons, you know the number of electrons. And you should know this. Hint, I can't write on here, but, oh wait, hold on. You should know. Hint, no. In fact, when I took notes when I was in undergrad and grad school, if I put stars and an arrow, that meant it was important. I should know it. And if it was really important, I do the stars, the arrow, and IMP. That means important. You better know this. The atomic number, and I'm using abbreviation because I'm lazy. Atomic number equals the number of protons, also equals the number of electrons. Know this. Commercial again for chemical symbols. I'll never ask you, but don't forget, chemical symbols are 1, 2-letter abbreviations. First letter of the element is always capitalized. Second letter, is, if there is one, is lowercase. Here are the elements. I'm not asking you to learn the whole periodic table. Now, let's go back to the periodic table. Let's do a little practice. If I were to ask you how many protons and electrons are in nitrogen, you should know nitrogen, chemical symbol N. The atomic number is 7, therefore the number of electrons and protons are 7. And thank you for those of you who are putting in the right answer. All right, I'm going to let you have some fun. How many electrons and protons are in sodium? I'll help you today a little. Time out for a tea break. Atomic number equals number of electrons and protons. So sodium has 11 protons, 11 electrons. Oh, let's go into the high rent district. How many electrons and protons does gold have? I'll give you a couple seconds, see if you can find it on the periodic table, then I'll show you. You didn't find it, gold is right here. AU is its chemical symbol. How many electrons, how many protons? Atomic number is 79. Therefore, it has 79 electrons, 79 protons. And the next time you're at a party and you're admiring somebody's gold ring, you can tell them, do you know the gold in your ring has 79 protons and 79 electrons? Don't. People do not want to learn that. Let's see, any questions going on? Okay. So see, chemistry isn't that hard, and it's even fun with Dr. White. All right, now, I will never ask you the definitions on this page, but the important item or concept and item in chemistry is the periodic table, which I just showed you on. And it's based on what's called the periodic law. When elements are arranged in order of increasing atomic number, elements with similar properties occur at periodic, regular reoccurring intervals. And the periodic table is a tabular arrangement of that, the periodic law. This I will never ask you on a test. Now, there's certain groups in the periodic table. Those are the vertical columns. I'll show you this in a second. Then, which aren't too useful, but somewhat, are what's called the periods in a periodic table. Those are the rows. Now, let's go to the next slide before we go over. Now, there's certain groups that are very important that you should know. And those are, the groups are the alkali metals, the alkaline earth metals, the halogens, and the noble gases. Let's go to periodic table. All right, if we come here, excluding hydrogen, lithium, sodium, potassium, so are the others, but these are the only three here, are called the alkali metals. And that's just the name. I don't know how they came up with that. Someday I'll look. Now, if we go over here, magnesium and calcium are the alkaline earth metals. So lithium, sodium, potassium, alkali metals, this column, second column, all these, but I've only asked you to learn magnesium and calcium, are the alkaline earth metals. Now, if we go all the way over to the side, and I'm surprised they don't have it, but fluorine, chlorine, bromine, and iodine are called the halogens, and you should know that. Those second to the last column on the right are fluorine, chlorine, and bromine, iodine are the halogens. And if I ask on a test, test number 1, give an example of a halogen, you could put down and say the name and the chemical symbol, bromine, Br, fluorine, F, Cl, chlorine, or I, iodine. And those are the halogens. I've heard that name before. How many of you have heard the term halogen lights? If you go to Chicago, you've seen them, the super bright car lights, halogen light. That's what I'm asking. And why are they called halogen lights? Oh, they're filled with halogen gas. And that, when you put electrical force into it, electricity, makes a very, very bright light, much lighter than your traditional wire light bulb. Now, I bet most of you have the LED light bulbs. I hope you do. I switched over a couple of years ago, all once in my house, because they save energy and last forever, almost. So let's look at the periodic table again. If I were to ask you, give an example. Oh, wait, there's one last column. The very last column are called the noble gases: helium, neon, argon, krypton, xenon, radon. I don't think I asked you radon. Maybe I did, to learn that. Now, years ago, up through 1995, these were called the inert gases because they didn't react. But then some very ingenious chemists found if you beat the heck out of it, that's a chemist's way of saying reacted under extremely strenuous conditions that he found, you could make these react. So they could no longer call them the inert gases, so they now call them the noble gases. Now, every once in a while in class, I will say inert gases, oops, I made a mistake, noble gases, because most of my adult life, they were called the inert gases. An example would be, if I ask on a test, give an example of the name and chemical symbol of a noble gas. Argon would be one, Ar, neon, Ne, helium, He. Now, helium is the stuff they put in balloons you buy, and it makes them float because they're less dense than air. Also, if you've ever had a tank of helium to play with and you get some in your lungs and you start talking like someone real high voiced cartoon character, and that's helium. Why that does that, I have no idea. There's a scientific reason, but I don't know it. Oh, important thing I forgot to mention. Things I discuss in the lab are never on the hourly exams. Things I discuss in lab, I never put on the exams for the lecture part. I keep them separate. Everybody can go like this. So you should know which column is the alkali metals, first one, which one of the periodic table is the alkaline earths, second one, which is the halogens, the second from the right, and the noble gas is the column all the way for the right. You should know which atoms of the ones I asked you to learn are in each of these groups. Like example, krypton is a noble gas. Chlorine is a halogen. Potassium is an alkaline metal. And we just did, let's do it again. Well, we just did this. Let's talk briefly about the atomic mass. I'll come back later on the semester. The number at the bottom here is called the atomic mass, and it's an important number we'll be using. I'll teach you about it later, but let's do one more of each. Why don't you find how many electrons and protons does sulfur have? And it's a rhetorical question. See, everybody's getting the hang of this. First of all, you have to know sulfur chemical symbol is S. The atomic number is 16. Therefore, it has 16 electrons, 16 protons. The atomic number tells you the number of protons and electrons. Oh, let's do one more. Let's go to a chemical I worked with, nickel, or element I worked with. How many electrons, how many protons does nickel have? And give everybody time to figure this out. This is something I could ask on a test. Oh, I'm giving away all the juicy stuff to you. All right, and time's up. Nickel, the chemical symbols Ni. Its atomic number is 28. Therefore, it has 28 electrons, 28 protons. So we've done some practice today, which is good. Now, you've heard these terms, and let's go over it. I'll never ask the definition, but you should know some examples. When we talk about a metal, that's an element that has characteristic of luster, thermal conductivity, electrical conductivity, and malleability. Now, examples of metals, not all of them, but examples would be aluminum, copper, gold, silver would be one, lead, tin, zinc. Now, what's luster? Luster is the fact you can shine it up and it makes it nice and shiny. The gold in my ring has luster because it's shiny. If I polished it more, it'd be even shinier. I've had it a few years. Hold on, I shouldn't do this, but can you see the number there? 1972. That's the year I got my bachelor's degree from IIT. Oh, I shouldn't have said that. Oh. Anyways, the ring has luster. Now, what's malleability? I think you know what electrical conductivity, electricity flows through it, and what is thermal conductivity, heat flows through it, which is why your pots and pans are made out of metal. So when you put a flame underneath, it heats up the liquid inside by conducting the heat through the metal. But what's malleability? Means you can pound it out and make it real thin. How many of you have ever seen gold leaf foil that they put on books? It's like onion skin, very thin, pounded out. Now, give me about 30 seconds more and then we'll finish up, and I'll do, like I promised, those who want to leave can leave. Those who want to stick around for learning how to eliminate test anxiety can stick around. Now, have you ever seen aluminum foil like you use in the kitchen? One side is shiny, the other is dull. Why? Because when they make aluminum foil, they run it through rollers and make it thinner and thinner because it's malleable. But when they polish it, it's so thin, they just had the one sheet, it would rip. So they put them back to back and they can polish the tops in the bottom of the double layer, but in between doesn't. And that's why your aluminum foil on one side is not shiny. With that, I finished for the day for the actual lecture, and I'll do in a second, but first I'll say to everybody, stay gesund, be healthy, have a great next couple of days and weekend, work on the problem sets, and have a good time. I had to get that in at least once. All right, I'm gonna be shutting off the video because I don't